Guys, I'm kind of mad because I've already done this last little bit, but it didn't record. So I'm going to do it again really quick. All right, so because you really need this part. This is Quick Check 911. So it's saying which one of these situations has the largest power output. Well, we have this equation. But what you need to remember is that work can equal force times distance. So power could equal force times distance divided by time. And do you see a force given in any of these situations? No. You see mass. Well, remember, you can find force by taking mass times gravity times distance. So these are 3 ways that you could find power. All right, so if you do this last one for part A, so you've got mass of 80 kilograms times gravity times the distance of 10 meters divided by 10 seconds. You should get, let's see here, 784 watts. If you do the same thing with the information given for part B, you should get 980 watts. Part C is 784 watts, and part D is 627 watts. So part B is your answer there. All right, this is the very last slide. So this is saying that a factory uses a motor and a cable to drag a 300 kilogram machine to the proper place on the factory floor. What power must the motor supply to drag the machine at a speed of 0.5 meters per second? And then it also says that there's some friction of 0.6. So this says that there's a mass of 300 kilograms and it wants us to find the power. So there's a speed of 0.5 meters per second and the coefficient of friction is 0.6. Why is it kinetic friction? Because it says that it's obviously going at a speed of something, so it's moving. Okay, so this is wanting us to find power. Power, we know, is work divided by time. Am I given any kind of time in this situation? No. Okay. There was another way to find power. We could also find power by taking force times velocity. Okay, so could we figure out some kind of force that's involved here? Well, it says that there's a cable. So typically a cable is like a tensional force. And we also know that there's friction involved. It's at an equilibrium. So we set it equal to 0. So tension is actually equal to the kinetic friction. Well, could we find the kinetic friction? Yeah. We have all of the information for that. So let's plug that into our force here. So we've got kinetic friction times normal times the velocity. Kinetic friction, normal is mass times gravity times velocity. So you've got 0.6 times the mass times gravity times this velocity, which is equal to 882 watts. Okay, so just remember there's a couple of ways that you can do power. All right, hopefully you guys have all of the PowerPoint recorded now. If you guys have any questions, don't hesitate to ask me. I'm working on getting your homework put in there for mastering physics, and of course your grades put on, which I haven't been able to even look at yet. But anyway, if you have any questions about anything, don't hesitate to give me